All right, so I think this is recording. Let's take a look here. We have a quadratic inequality. Let's solve it two ways. We'll solve it algebraically with a table, and then we'll solve it analytic geometry by looking at the graph. So in either case, we want to factor this with a leading coefficient of 1. Um, it's pretty easy. You don't have to necessarily come over and make your x, because you can just look at it and see that you need two values. When multiplied together give you 10, but when added together give you -7, a -2x and 5x in our table. But with a leading coefficient of 1, like I say, all we need is the numbers. So we've got x minus 2 times x minus 5. That gives us two critical points that we can place on a number line. And our first decision will be whether to shade in, include our endpoints, include these critical points, or exclude them. That's determined by the inequality. Since it's greater than or equal to its underlying, we include these endpoints in our solution set. And now we want to pick a test point from each region. Some number that's less than 2, I would pick 0. Some number that's between 2 and 5, I would just arbitrarily pick 3. And some number that's greater than 5, I would pick 6. And now I'm just going to organize this information in a table where in this column I just label it region or test point. And in this middle column, I can use the original inequality or the factored form. And then in my last column, I can just refer to it as my truth column. It's telling me to shade or not to shade each region. So in region A, we said, hey, why not try a test point of 0? This would give me -2 times a -5. That's a +10, and it's true that 10 is greater than or equal to 0. So we're going to end up shading this region. If I pick a test point from B, like 3, 3 minus 2 is 1, 3 minus 5 is a -2. That product is -2, but negative numbers are not greater than or equal to 0. That's a false statement. So I'm not going to shade that any point in that region. So now in C, I want to use a test point of 6. 6 minus 2 is 4. 6 minus 5 is 1. 4 times 1 is 4, and 4 is greater than or equal to 0. That's a true statement. So I'm going to use that region in my solution set. So I want to shade in all the points in region A. There's nothing special about 0. When I picked it, I could have picked any point, and it would have led to a true statement. Any point in region C would have led to a true statement. So here's a picture of my solution set. To write that as an inequality, I would have x less than or equal to 2. I need that or statement because I'm either in this interval or this other interval, and x greater than or equal to 5. And so here's my final answer. And there's a graph of that answer. Now, let's shrink this up and solve it the same problem again, only using graphing techniques, analytic geometry. So I have to factor it, so I'll keep that part, and then this, well, I'll just shrink up out of my way. All right. So when we factor this, before we had commented that it divides the number line into 3 regions. If we use that number line as the x-axis and this 2 and this 5 as the x-intercepts, we know that a quadratic with our largest exponent of 2 that the graph is a parabola. And with the leading coefficient being positive, we know that parabola opens upward. And this 2 and this 5 are the x-intercepts. So a rough sketch of my parabola is something like this. And now it says greater than or equal to 0. So greater than 0 is above the x-axis. So the portion of the parabola that I'm interested in is above the x-axis. This is the portion that I'm interested in, including the x-intercepts, because it's greater than or equal to. So I need to describe all the x-coordinates of these points. Well, let's look at a few of the x-coordinates. Here's a point in my shaded region. That x-coordinate is down here to the left of 2. Here's another point in that shaded region, and that x-coordinate is to the left of 2. Over here is a point in the shaded region, and that x-coordinate is bigger than 5. Over here, so all of my x-coordinates that are on this shaded part of the parabola, the part that's greater than or equal to 0, above the x-axis, all of those x-coordinates lie on this portion. They have these values, and we can describe that as x less than or equal to 2 or x greater than or equal to 5. Same answer, same solution set as before, and some people might find it easier or quicker, maybe quicker is a better word, than constructing a table. Now, of course, you can take some shortcuts with the table and stuff by marking the 0, the 3, and the 6, and then just plugging it in and doing the arithmetic and shading. The table was just a suggestion to be organized, but if you've done it enough, then you can probably do it without the table and just plug it in and shade the number line. I would suggest making the table because it'll eliminate silly type of mistakes, just as I would suggest sketching the graph of the parabola and shading in the portion that you want can help stop silly mistakes as well. Don't be afraid to ask questions. I hope this helps, and I will talk to you later. Bye.